Okay, here we've got the region that's supposed to be revolved about this axis of revolution, the line x equals 2. It's this red region R that we're going to revolve, and the shell method uses basically this formula. We're integrating along the x-axis. 2 pi times the definite integral from a to b of the height of a typical shell times the average radius, which the average radius is the distance from the axis of revolution to the center of a typical shell. So it's like that distance right there. The issue with this problem is that the formula for the height of the shell changes as you cross the x-axis because we have a different formula for the y-coordinate at the bottom. So for example, if I want the height of this shell when x is between -1 and 0, I'm going to take the x-coordinate or the y-coordinate at the top and subtract the y-coordinate at the bottom. That gives me the height of the shell. And the average radius will be the x-coordinate at the right, which is 2, take away the x-coordinate, which will be, like, for example, if this is a -0.5, 2 minus a -0.5 is 2.5. Would be the distance from the axis of revolution to the center of the shell that we're revolving around that line. Okay, so here's the setup. We have, again, 2 different formulas. One for the left of the x-axis, 2 pi, there's the y-coordinate at the top, minus the y-coordinate at the bottom. So this gives us right here the height of a typical shell. And 2 minus x is the average radius. And of course, there's the thickness of the shell. And then for the second region, this formula for the height of a typical shell changes right here. Y-coordinate at the top remains the same. The y-coordinate at the bottom is just an x minus 1 instead of a minus x minus 1. So if you combine similar terms for the typical height, then multiply 2 minus x times that trinomial, then find an antiderivative, add them together. You might call this v sub 1 and this v sub 2, and add them together. You'll have your answer. And by the way, the washer method would have worked, but it would have been quite a bit more complicated because we would have had to solve each of these equations for x and then gotten outer radius squared minus inner radius squared. So I will post the link to the graph that where this picture came from, and that graph has the answer, but you should try to work it out first. See if you can come up with the correct answer. There you go. Hope that helped. If you have any questions, post a comment.